In the field, surveyors face a variety of issues, and the most common is calculating the surface area of a specific field. Field irregularities are frequent, which makes direct calculation of their areas challenging. In some circumstances, fields are divided into a number of regular areas such as triangles and rectangles, which are surfaces that may be determined using simple formulas. All of these areas are computed separately, and the total area of the field is calculated as the sum of them. Before anything else, it is necessary to first study the field. They should look at the field to see its shape before commencing to measure it. It is unlikely for a field to have simple geometrical shapes. It has primarily curved sides and can have a complicated shape. That is why it is important to know its original shape to be able to come up with a solution, such as dividing it into simpler shapes to use simpler formulas. In most cases, however, the shape of a field can be approximated by a simple figure. Curved lines can be approximated by straight ones, and the field can be split up into triangles and rectangles, which can all be measured and used to calculate the area of the field.
Objective. The objective of this fieldwork is to develop and acquire the skills of determining the area of a polygon in the field using tape by dividing the area into triangles. Instruments and accessories. In doing this fieldwork, several materials are necessary, including range poles, measuring tape, markers like chalk and marking pins, and lastly, plumb bobs. Range poles, a surveying instrument that is used to mark the location of a point or the direction of a line that is required to be seen from a relatively long distance. Markers are used to mark each distance measured by an instrument. Plumb bob is a metal weight with a pointed end which is suspended by a string 5 to 6 feet long. The bob is used to vertically project a point and may be used at one or both ends of tape as well as the tape's other ends. Measuring tape or a tape measure are used in surveying to measure horizontal, vertical, and slope distances. Tapes are issued in various lengths and widths and graduated in a variety of ways.
For area determination by base and altitude, the following steps are: Step 1. The instructor assigns the locations of 5 points in the field, and the students will mark these points with marking pins or chalk. Name these points, which will serve as the corners of the polygon, as A, B, C, D, and E. Step 2. The chief of party divides the polygon into 3 triangles by taking into consideration that the divisions should be easily measured. Name the triangles as A1, A2, and A3. Chief of party supervises the work performed by surveying groups in the field. As a supervisor, the survey party chief is first involved in the planning portion of the ground surveys. Step 3. Measures the base of the first triangle chosen in the polygon using tape. Step 4. Then measure the length of the altitude of the first triangle. The determination of the altitude is part of taping operation, which will be discussed by the instructor. Step 5. Record the length of the base and the altitude on Table 3.1, Area Determination by Base and Altitude. To get the area of the triangle, divide the product of the base and altitude to 2. Step 6. Repeat steps 3 to 5 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.
For the procedure of the area determination by two sides and an included angle, the following steps are: Step 1. The same field described in A, area determination by base and altitude, will be used for this method but change the designations on the corners. In example, use F, G, H, I, and J instead of A, B, C, D, and E. Step 2. Divide the polygon into 3 triangles. Step 3. Measure any two sides of the first triangle chosen and record these measurements as sides A and B. Step 4. Determine the included angle between sides A and B and record this on Table 3.2. Area determination by two sides and an included angle. To get the area of the triangle, divide the product of side A, side B, and sine of the included angle to 1/2. Step 5. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.
Area determination by Heron's formula. Step 1. The same field described in A. Area determination by base and altitude will be used for this method, but change the designations of the corners. Use K, L, M, N, and O instead of A, B, C, and E, and F, G, H, I, and J. Step 2. Divide the polygon into 3 triangles. Step 3. Measure all the sides of the first triangle chosen and record these 3 measurements as side A, side B, and side C. Step 4. Determine the semi-perimeter of the first triangle by multiplying the perimeter of the triangle by 1/2. To determine the area of the triangle, substitute the values of semi-perimeter, side A, side B, and side C to equation. Step 5. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.